Good day. You should have a sheet that says predicting products, rules of thumb, and amazingly looks like this. This is a very important sheet. You're going to use this with your periodic table and your table of complex science to predict products. Hopefully you've gotten good at balancing equations. In balancing equations, you're given a skeleton equation with all the formulas, and all you have to do is put in coefficients. You have to classify reactions. When you've done classifying reactions this week, you had basically the whole equation, left and right. But here for predicting products, all you are given is the formula of the reactants and no coefficients. So you have to put all your skills together to classify just with the reactants, write proper formulas of the products because you understand the patterns, and then balancio the equations. Now, when you attack these questions, this is telling you the order in which to do the questions. It's telling you first go after combustion. Second, you're going to go after all the decomposition reactions. Then the synthesis, then the single replacement, then the double. And basically we're going from the easier reactions to the more complex. And there are some advantages to doing it this order. Every year I get people who ignore the sheet. They think they know better than me, and they're clueless. They can't do it, and then they expect sympathy from me. And surprise, surprise, sympathy is not one of my strong suits. So, pay attention. We're going through this sheet, and then we're going to do 10 examples in the next video that hopefully become a good resource for you. Combustion means O2 is a reactant. The reactants are to the left of the arrow. That means you're going to see O2. It has to be by itself. It has to be an element. It cannot be in the form of a compound. Now the oxygen can react with a metal or a nonmetal. And when it does that, it's actually going to be getting together with them according if it's ionic to charges. If it's going to be a nonmetal being burned, then usually you have a little latitude in what formula to write. If it's an organic compound, and we say organic, oh, they've got carbon and hydrogen, they may have other things, they might have oxygen in this game. But here's a nice thing, it says always. In chemistry, often we don't have always. Always don't have often. Anyways, always, always, always CO2 and H2O. So if I take sugar and burn it, I'm going to make CO2 and H2O. If I take gasoline and burn it, I'm going to make CO2 and H2O. If I take propane and burn it, CO2 and H2O. So I automatically write down those in my products, and then I'm ready to balance. Now the combustions, those reactions with oxygen, by doing those, they're now out of the way. They won't come back to haunt us when we're looking at single replacement. Door number 2, decomposition, the dead moose reaction, where you're starting with only one material and it's going to be breaking apart. So, how do we know it only has one reactant? There's no plus sign to the left of the arrow. If you don't see a plus sign, if all you see is one compound there, you know for sure it's decomposition. Usually, it will just simply split into its elements. And you've got to be careful, got to remember the diatomics if they are at the back end of the compound, things like chlorine. But you have to memorize how KClO3 and NaClO3 and LiClO3 break apart. They are a special case, and on the next video, we're going to give you one example, and you're going to see that KClO3 would split into KCl plus O2. NaClO3 splits into NaCl plus O2. LiClO3 splits into LiCl and O2. And you're saying, why O2? Because when oxygen is out of the compound by itself, it's going to be diatomic. And then you balance. But we'll show you an example of that in the next video. Now after decomposition, it gets tougher. But we've got rid of those types, so we're now down to synthesis. What you're looking for is an element plus an element. So no compounds in this game. It's possible that you could have compound and an element getting together and have this happen. But we will not ask you for that in Science 10 or even Chem 11. So if you see an element plus an element, you know it's synthesis, and they're going to make a single compound, and if it's ionic, you have to write the proper formula for it. Otherwise, I have to give you a little more info. So usually I'm going to have a metal getting together with a nonmetal for the synthesis. Number 4, single replacement. So this is the idea. We've got a couple at a dance, and we have a single element shows up at the dance, and that single element boots one member of the couple out and gets together with it. So we have an element of compound. The element boots something out, replaces. In case of a metal, it boots out the metal. In case of non-metal, it boots out the non-metal. We have an activity series for it and all that great stuff. But you're going to end up making an element plus a compound. And again, you must remember diatomics. So you have to be able to classify these by knowing the difference between elements and compounds. This is element compound. If you saw compound plus element, same thing. Now the nice thing is you don't have to worry about things with oxygen. Something reacting with oxygen, because we took care of that with combustion. That's why we did combustion first, so it wouldn't become a nuisance for single replacement. The last one, number 5. Number 5, double replacement. There we're looking at a compound plus a compound. These will be 2 ionic compounds, and the metal and the nonmetal will be recombining. This is the old double date gone sour. The front end of one compound gets together with the back end of another compound, and vice versa. They're switching around, and we have to write proper ionic formulas. So when we're doing these kind of things, once we've written out proper formulas, then we are ready to balance the equation, and we're home free. You have to watch out, though, for neutralization. If you see a compound and a compound, you've got to make sure that you don't have an acid and a base. If you have an acid and a base, then you don't call it double replacement, you call it neutralization, and you will make a salt and water. If you have an acid plus a salt, that will be double replacement. It is not neutralization. If you have a base plus a salt, that is not neutralization. That's double replacement as well. It's only if you have an acid and a base that you make salt plus water. Think about it. The acid has an H at the front end. The base has an OH at the back end. Together you make HOH or H2O. That's how you make the water. And once you've done that, then it's a piece of cake. The salt is going to be the metal from the base, and the non-metal from the acid getting together according to ionic rules. Seeing examples will really help this make sense, but you should always have this sheet handy while you're learning how to do it. And if we had a test, good news, you would not be allowed to have this sheet. You actually would have to understand what you're doing. It does say at the bottom, it's not easy. We're taking a lot of the skills that you should already have or be building, and we're applying them. So if you can do this stuff, it's a good sign that you are getting the hang of chemistry. If you don't know your diatomics, that's disgusting, offensive, outrageous, and semi-contagious, because when we did covalent, I said, memorize the diatomics. No offense. Do you practice? You got to practice this stuff. So we're going to do 10 examples in the next set of notes. In tomorrow's lesson, we're going to do 10 more examples. That means you'll have 20 examples to look at as you chug through a number of sheets on the wacky world of predicting products. Some of you are going to do well, and then it says the test will answer these questions, Sadly, no test. Interesting year. So good luck with this.